Thank you, Krishna.
Good morning. It's my absolute honor to extend the warm word of welcome to each one of you. You all been here on this Friday morning for this webinar stands to be a proof of your brain starving to learn new things. Your continuous support makes us to showcase a different set of intellectual webinars that can definitely serve you enough for the hunger of your brain. Our St. Joseph group of institution has amplified and grown in many folds over 25 years and successfully crossed a silver jubilee. And we are into its 26th year. I strongly believe growth is not only vertical dimension, it is also horizontal phenomena. So when growth happens, inclusiveness must happen. The dynamic gentleman behind the growth of this institution is our beloved chairman, Dr. B. Babu Manoharan, whose tireless efforts makes us to give our 100%. It's always heartening to mention our beloved managing director, Mrs. Jessie Priya, and beloved director, Mr. Sashekar, whose propulsive idea drives us forward. I take this opportunity to thank our beloved principal, Dr. P. Ravichandran, for his continuous support and motivation. I also extend my welcome to the two young and dynamic industrial experts, Mr. Deepak Kumar, Senior Engineer, R&D Division, AVTech Limited, and Mr. Gautam Raj, Senior Engineer, Product Design, Mercedes-Benz R&D India. They have come up with the topic, Industrial Tools for Design and Development. Let me give you a small brief note about the topic. The customary track of putting an urge on the performance criteria and durability of industrial design and products have just lost its charm. Expectations on performance aspect are inevitably hidden and they are the mandatory in minds of customers. Having got into global competition and modernity taking the driver's seat, the aesthetics have become the fuel of the change. More the number of variants in the design tools, more is the utility of the design tools. These design tools not only remove the blockades and bottlenecks of the existing design, but adds the aesthetic sense as well. The knowledge on various design tools, the inbuilt features, and their flexibility on customization are to be definitely enhanced and enriched by the design engineers. I hope this webinar could throw a bright light on the industrial tools and their utility in performance enhancement and on the outlook of industrial products. My mom always used to say, it is not always how much you do, but how you do it makes life beautiful. It's all about involvement. Involvement is the key to success. Let us all keep our eyes open to see the presentation and ears open to listen to the intellectuals. On behalf of St. Joseph Institute of Technology and Department of Mechanical Engineering, I once again welcome you all. Thank you.
Thank you, Ranjit sir, for your warm welcome address. May I now call upon Mr. N. Suresh, Assistant Professor, Department of Mechanical Engineering, to give away the introductory address of today's speakers.
Good morning, dear participants. Today we have two young and dynamic engineers who is going to present the topic industrial tools for design and development. Product design and innovations in product is a key success to any industry which adapts to the technological change. So understanding the tools used in design and development cycle is in much required for aspiring engineers as well as to the academicians, because academicians objective is to make the students industry ready. So now today we have two young and dynamic engineers to share their presentation. One, Mr. Gautam Raj, who is currently working as Senior Engineer in Research and Development Division of Mercedes-Benz. He is proud alumni of our St. Joseph Groups of Institutions and graduated in the year 2014 in Mechanical Engineering from St. Joseph's College of Engineering. Prior to Mercedes-Benz, he also worked for MacTork Industries and AVTech Industries. And the second speaker, the Mr. Deepak, who is currently working as Senior Engineer in Research and Development Division of AVTech Limited. He is graduated in the year 2016 in automobile engineering from SRM University, Katangalatur. Avtech is one of the leading manufacturers of automatic transmission system for on-road and off-road vehicles. Now I am handing over the session to the Gautam and Deepak. Thank you for giving me the opportunity introducing them.
Thank you, Mr. Suresh, and thank you, Team SJIT. I would like to share my screen.
I request all the participants to pin the today's speakers to pin the presentation. Gautam Raj started to present their screen. I request all the participants to pin Gautam Raj presenting screen so that the screen will not be navigated throughout the session. I repeat, I request all the participants to pin Gautam Raj presentation. Thank you. Yes, Gautam Raj, you can start. Thank you.
Hope my screen is visible to all.
Yes, it's visible.
Yeah, thank you. Hello, everyone. Very good morning to all of you. It's my pleasure to extend a cheerful welcome to you all to join hands with me for today's webinar session on industry insights. In this regard, I would like to thank once again and Mr. Suresh Krishna Kumar and all his team, along with the faculties and the management of St. Joseph's College of Engineering and Institute of Technology for arranging this webinar. So I see this as an opportunity to connect with the academic teachers, the future engineers, and the entrepreneurs. I highly appreciate the effort of St. Joseph's Institute of Technology and College of Engineering in this regard, always trying to bridge a connection between the industry people and the academic people. So before I begin into the subject, I would like to introduce our team. Maybe I will start with my introduction. Later, part Mr. Deepak Kumar can give his introduction. So my full name is Gautam Raj, and I am from Osur, and I am graduated from St. Joseph's College of Engineering in the year 2014. I have totally around 6 years of industrial experience in product design and development, maybe to be more specific on the design of transmission and the drivetrain elements. And so I joined my career as a GET in MacTorque, which is a subsidiary of LNT, and in a part of industrial gearbox design team. So where we used to make the specific industrial solutions to LNT and the defense products. A year later, I got an opportunity to be a part of Hindustan Motors, which is formerly known as Avtech Limited, part of CK Guerrilla Group. I was in an automatic transmission R&D team, more specifically working on the defense product. I was part of the entire design and development and on the final validation cycle for one such product known as we used to do the design for the transmissions for the tankers Indian Army, one of the product called as BMP. So I served there for around 4 years, and moved to my current organization. It's been around 11 months over here at Mercedes-Benz as a part of product design for dual clutch transmission for the passenger car vehicles. So far, I have published around 6 papers in the various international conferences and held 3 patents on the gear train architectures. So this is a short introduction about myself. I would like to hand it over to Deepak to give his introductory note.
Thank you, Gautam. So, before starting, I'd like to thank Mr. Suresh sir, Krishna Kumar sir, and the SJIT team for giving us an opportunity to talk in this webinar. So, Suresh sir has already told you most of my introduction, so I'll just make it brief. So, I'm Deepak Kumar from Chennai. So, I've been working in Avtech since 2016. I joined as an engineer trainee in the R&D of off-highway transmissions, particularly automatic transmissions. So I've been in Avtech since 2016 till now, and we also have one more team member, Mr. Dhanasekaran K, who is a CA analyst in Avtech. He also joined in 2016. However, right now he is not a participant of this webinar. So Gautam, we can take it forward from here.
Yeah, thank you, Deepak. So let's begin this agenda. Before I begin it, let this webinar session be more on the interactive phase. So whenever you have any doubts at any phase of this webinar, please free to pause us at any point, and we will have a debate on that, and we can move forward. Or else we will be having a separate Q&A session at the end of this presentation, and we can discuss over there also. And you can post the questions over the chat also, so we will be taking up at the later point. So few of the contents, few of the questions which you may be asking may not be answerable at this moment. Surely we'll be taking up those questions and will be reaching you in person. So yeah, and about this disclaimer, so the contents that we share over here are taken from the various internet sources, and the things related to our company's future and the technology or the strategy of our either the current organization or my previous organization is not disclosed over here. So yeah, we'll go to the vision of our team. So we, the team academic to industry, we are a group of young engineers under the umbrella of an experienced professional. So our aim here is to make you a student to understand what is expected by the industry and give you a glimpse of what is happening in the industry across. So I will add this pointer. Yeah. Yeah, so this is basically in this regard, we would like to lift the young engineers with the basic technological tools which we use on the day-to-day basis in most of our fields. Either you wanted to pursue your career here as a mechanical design engineer or the CAD engineer or a CAE engineer, or be a production engineer. So what are the industrial tools that we are going to discuss in the upcoming slides will be useful in one or another way. So also the reason why we started this academic to industry group is whenever we joined as a GET in the organization, as in we were not knowing about these tools, and whatever the opportunity that few of my seniors was having, they used it to succeed in a much faster way than the people over there. So that's the reason we thought we will bring what is happening in the industry to the academic people. So in a simple words, we are trying to bridge the gap between the industry expectations and the young academic engineer skills. So we will move on to this topic about in this slide you can see I will be explaining on, or I will be taking you through what is the industry expectation, and as a young academic engineers, what are the skills that you guys will be possessed. So now let's take a look on this. So the guy who is passing out of the college will be having the bachelor's degree in mechanical discipline without the specialization in automobile or the production fields. And the very good thing is about the practical and the theoretical knowledge that you guys possess over these 4 years, as the very strong theoretical background and the lab work that you do all these things adds a plus point to you, provided you have done your final project by your own. And nowadays I can see most of the colleges are encouraging their team members, encouraging the students to participate in the real time events like Baga, Supra. And even I saw the video where Mr. Krishna Kumar has showed tractor events, so I was really surprised. And these things were making the students to realize whatever they have learned over the theory, can be implemented in these practical sessions. So this adds a good portfolio to them. And few of the students even will be publishing the conferences, publishing whatever they have done so far in their curricular, and they might have come up with a few of the papers in the conferences and the symposiums. So this is what more of less who the student whoever is passing out of the industry will be having these skills. Now let's look at what the industry is expecting. Yeah. Yeah, now let's look at like what the industry is expecting from you guys. As whenever we say as a industry, the term called as industry ready engineer, this is a common term that nowadays like it is becoming more popular among the industry. So as a engineer, whenever you enter into an organization, you will be in a GET role. It means a graduate engineer training. And whenever we say as industry ready engineer, whoever joins as a GET, the industry expects them to work on their day-to-day projects with the minimal training. I can remember like my seniors in the years of 2010, they were telling like whenever they are passed out from their curriculum, they used to have the exclusive 1 year training as a GET, followed by a 6 months as a specific training to the departments that they go into. But now because of like because of the industry changes and because of the time and money factor as well as the resource optimization factors, now everything is getting changed. Now the guy who is entering as a GET, the industry is expecting him to be a part of the team within the 2 or 3 months, and the industry is expecting the guy who is entering into the industry with the basic tools that they use in the industry. And last but not the least, about the strong basics, the one thing I need to tell about this is, so I am part of this R&D from past 6 years, and whatever we do in the R&D, whatever the problems we face, everything is related to the basics of the engineering. So either it be the thermodynamics or the strength of materials, or be the machine elements. So this basics will be always be helpful for your when you enter into the industry. Yeah, so next I will take you through this product development cycle. So this is what like in most in almost all the industries, industries will be following this product cycle. This is not only pertaining to one industry, it is common across all the industries. Either you take it as an energy sector, or it may be in the marine sector, or it may be in the windmill sector, or the automobile. So this product development cycle is one among the same, with some modifications pertaining to their own industries. So let's have a glimpse on this. So everything, it starts with the business planning. Whenever I say as a business planning, there is someone called as business analyst who is working in this business planning team. The role of the business analyst is to predict how the market is, how the scenarios will change down the line, 5 years, 10 years, or the 20 years in the near future. So this business analyst will come up with a proposal, thinking that our product portfolio, how it should be over the time. So I can remember when I joined when I joined as an engineer in Avtech Limited, one of the business analysts came with a proposal of electric powertrain for the dump truck vehicles. When I say as dump truck vehicles, it is like used in the off-highway industries. It's not similar to what we see in the normal roadways. So its payload, its load capacity is more than 100 to 200 tons. So I was thinking at the time, because that is the time where this electrification started, and like many of the products are getting electrified. I was thinking only the passengers cars can be electrified. How come this much big ton vehicle can have this electric powertrain? Then what has happened is, recently I read one article where the BEML has come up with the electric powertrain of 200-ton capacity. So whatever the analyst, my business analyst predicted that time, has come up to the true. So this is was the major role of the business analyst in an organization, where he will be seeing what will be the future ahead of it. When the business analyst has come up with a proposal, he will be having a discussion with the product planning team. This product planning team will always be in touch with the business planning, and they will be coming out something called as specifications. Whenever I say as specifications, it means like whatever the product we produce in the industry, it should be meeting with some or other expectations. Let's take the example of a truck. So whichever the truck, based on its application, either it be in the mining industry, or it may be in the on-way vehicles, it has its own specification. The truck in the mining industry will require more torque than what it is in the normal on highway roads. So in those conditions, they will be deriving with all the specifications whether my truck has to go to carry with so and so load and so and so torque and with so and so speed. So all these specifications will be derived at this phase, and once this is done, there is something called as business case team. Whenever I say as business case team, it is like more on the top level managers sitting across and discussing on the cost benefits and the rate of returns that is going to create to the industry, along with all the future plans down the 5 lines, 10 lines, what will be the revenues. Once they feel like everything is fine, they will be forming a separate teams in the across the organization, start from the production team to the R&D team to the manufacturing team to the quality team. There will be a separate dedicated team who will be working on these projects. So once business case is through, it goes to the design and development phase. So regarding the design and development phase, in the upcoming slide, I will take you in a very brief manner. I will explain you on each and every process how it is happening. So here, let's see on the sky level. So when it comes to the design team, so whatever the specifications they have finalized, so they will be converting this as a product, and this product, once it is designed, it goes to the prototype development. So what in this situation, the like various stakeholders, right from the purchase department to the manufacturing department, everyone will be involved over here, and whatever the design we have done, and it will be developed, and this developed product, once everything is completed, it goes for the bench validation. So whenever I say as bench validation, it means like it will be doing in the labs, whatever we see in the labs that is will be called as bench validation. So during this bench validation against the specifications, it will be tested against in the validation phase, and whatever the shortcomings against the specification will be communicated back to the design team, and they will be doing some alterations, and again they will be carrying out this task. So there is something called as pilot lot, which means like pre-production phase. Whenever like we start the production, there will be a pre-production phase, and this phase includes all the design improved points also, and they will produce the pre-finalized products, and they will put it for the field monitoring. So whenever I see as a field monitoring, and it means like you can see in the roads, like most of the cars will be covered with a sticker, and they will be doing, and you can, it is like whenever I see in Osur, or like a TVS company guys will be having their scooters, and they will be doing the field trials. It means like whatever the based on the real road conditions, they will be testing the air own product. So whatever we tested at the bench validation, it is just from the lab. I mean, in the lab condition, it will be the ambient condition will be 25 degrees. But when it comes to this field monitoring, it will be tested in the over in the cold regions, in the hot regions, everywhere it will be tested, and it will be monitored. And the monitored the parameters will be shared with the design team for their like final specification. With the specification, they will be doing the mapping, and once everything is frozen, it goes to the next stage called as product launch. Before it goes to the product launch, there is something called a series production team. What does this series production team do is like before the product launch, there will be a separate team who will work on the mass production. So whatever we developed in the prototype is just 15 to 20 components and for the testing purpose, whereas in the series production it will be for as a mass production, and like whatever the product, if it launch and goes to the customers, the requirement will be in more than lakhs. So we will be able, we need to set up a new new factory, or maybe the new assembly plant, or maybe be only the tooling change or the machine change. All those parameters will be analyzed by this series production team, and they will be ready before the product launch is happening. Once this is series production is ready, the product launch will be happening side by side, and the product whichever we design, and will go to the end customers. So whenever it goes to the end customer, they will be having their own feelings whenever we drive a car. Whenever I can give like whenever the MG Hector as introduced, when I was driving, I felt like few things to be modified. So we had an interaction with the service support team, and in turn, this service support team will always have in touch with the design team. So whatever the major modification that the customer is experiencing, say for example, any problem with the gearbox or any problem with the performance, everything will be communicated again with the design team, and this is how the loop in the product development cycle goes. This is not pertaining only to the automobile industry. You take any of the industry, it will be the same. Maybe you guys might have gone for many of the implant trainings. There you could have seen like any one of these stages, mostly on the series production stage. So when I was there in St. Joseph's College, I went for around 3 implant trainings in my and a few internship projects. So what I experienced is like one with the Ashley L team, so other is the Gandhimati appliances and few other things. So all there were about the series productions, and so you cannot see the entire phase that is happening in the industry. So this is what the background of the product development cycle. Next, let's move on to the design and development cycle. So the reason why we have bought this design and development cycle exclusively here is whenever you guys as a GET enters into any of the industries, either you will be placed in the design cycle, or I mean design team, or the development team, or be the quality team. And major of these teams will be like you will be working on these teams. So it's highly necessary for you guys to understand like what is happening in these teams. So I have taken here as an automobile, I mean car as an example, and I have just described here the various stages as whichever it is happening. So as I mentioned in the last slide, you can see that from the business case, once the specifications are finalized, it moves to the research and development team or the design and development team. So whenever the specifications is finalized and moves to the R&D team, a separate team will be working on this particular cycle. So right from it goes to the concept layout. Whenever I say as it goes to the concept layout, there will be a parallel team who will be working on the calculation base. When I say like as a specifications, there will be two kinds of specification in terms of size parameter and in terms of functional parameters. Whereas there will be a separate team who will be working on the size parameters of the car, and there will be a separate team who will be working on the calculation, whether it has to reach so and so gradability or it has to drive my car has to be having so much so and so speed. All those things will be looking after by the calculation team. So when the concept layout is there with respect to the length and height, all those parameters, as they will also do something called as benchmarking. This benchmarking activity is something very essential in the industry. When and the reason behind is whatever the product we manufacture, it should be saleable at when it comes to the market. Right? So you're like the entire this production phase will go for around 3.5 years. So whatever we introduce a product after 3.5 years, it should be matchable with the competitors specification also. So it is highly recommended, like we will be doing the benchmarking. And say for example, I'll take as an example, and our competitor having the so and so transmissions, and we will be benchmarking with the as transmissions, and whatever the features they have kept in those transmission, we will be trying to have something more than what they are actually having. So it means like whenever we enter into the whenever this product enters into the market, so we'll be a market pioneer. So these two activities come leads to something called as concept design. When I say as a concept design, roughly it is like a rough parameters, and this is how our concept vehicle looks like. Once the concept design is frozen, it goes to the some analysis team. Here the analysis team plays a very major role. So they will be analyzing whatever the concept we have made in terms of strength. Say for example, I design one axle axle, and that axle should have so and so torque. So whether it is matching those requirements, so everything will be calculated in this calculated by the analysis team, and the feedback will be given back to this concept team. So whatever the improvements they suggest, whether the diameter we have chosen is like, we will be doing the initial kind of design, but I mean initial kind of calculation. But however, other parameters, like with respect to ambient change, all those things we cannot calculate with our hand calculations. So it's always recommended, like we will be going with the analysis team. Here they will be doing the static analysis, dynamic analysis, any NVH behavior, crash simulation. Everything will be analyzed at this stage, and they will come up with the proposal that whether whatever design we have suggested holds good or not. And whatever the suggestion they give, we will be incorporating same in the design phase, and it will be converted as detailed design. In the detailed design, you can see, like when we call it as detailed design, it will be meeting all the specification requirements as listed by the business analyst in his specification list, and also the calculations and the documents, and also the like also with respect to FMEA, failure mode effective analysis, all the things will be recorded in this detailed design. Once we are through with the detailed design, and every process has its own timelines. Before we start, as I said, like business case team will give the deadlines for each and every process over here. As say, for example, concept layout will be doing in 5 months, benchmarking will be a parallel activity for 1 month, and concept design for 1 year. So it will be like a deadline based, and once we complete this detailed design, it goes for next phase is called as design review. When we say as design review, there will be a subject matter experts and the consultants, and who has a prior knowledge and the prior experience on these fields will be reviewing our design, and they will be giving their feedbacks. So they will always like a checker or against the specifications, and if they feel like anything to be modified, or like whatever the observation they see, they will again communicate with us, and desired the changes will be made in this design, detailed design, and again we will put it to the review committee. Once review committee has accepted our proposal, our design, so this will take for 2 months. For 2 months it will be only the review process will happen. Once everything is done, there is something called the second phase of the review, where other stakeholders will come. So once the design is completed, it goes for next phase, the review with other stakeholders from the procurement team or from the manufacturing team and the quality team. It is highly essential for us, like as a designer, to maintain a balance between this cost and the manufacturability, because whatever product we manufacture should be machinable within the company's machines, and it should meet with the company's cost also. That is the reason there will be always be review with these stakeholders, and these stakeholders will give their opinions, and whatever it is feasible, visible, without compromising the functions, we will be taking care in our detailed design, and we will put it forward for the development. So once the review two has successful with other stakeholders, it goes for the next stage called as proto development. This proto development is the phase where the prototypes are getting manufactured. When I say as a prototype, the reason is like it is only the 15 to 20 components will be manufactured at this phase, just to realize whether our design is correct or not. So this time, other stakeholders, as I mentioned, the procurement team will be procuring all the materials. There will be a different kind of procurement teams. One will be looking on the fasteners, one will be looking on the raw materials, other will be looking on the bought out items. All these phases, as they will bring it to the company, and they will manufacture it, and they will assemble. And once the assembly is ready, it goes for the bench validation. This bench validation, as I explained in the slide, so this bench validation, always the engineers over here, they will be having something called design validation plan. And it means like these specifications are converted into the testing parameters, and these testing parameters will be validated here. And after this bench validation is successful, the whatever the shortcomings in the bench validation will be communicated with the design team, and the design team will come up with the proposal of improving that. And before it goes to the field validation, the side by side the series tool development also will be taking place. And this tooling series tool is happened, and the parts produced from this to this series tool will be put into the field validation. And also the improvements from the bench validation is also captured before it goes for the field validation. So this field validation will go for 2 months, 3 months based on the requirements. So for a typical automotive industry, it always like if everything goes well, at least it will be done for 3 months. If at all there are changes, again this validation plan will keep on extending. During these various phases, as the feedback will be given to the design, and the role of a design engineer over here doesn't stop within this design review. He has to step in almost all the phases, whether it be the proto development or it may be the bench validation. He will be a part of this entire activity. I can remember for one of our tanker project, I stayed around 1.5 months in the field. It's in Rajasthan. So like even though my design activity completed at the very earlier phase, but the validation part at also we the design engineer who has designed should feel that how the experience is. So when I drive the vehicle, I feel like how good it is and what are the parameters it has to be improved. Those things will be judged only by us. So it's always as a designer, whoever enters in the industry will be contributing in almost all the fields over here. And this is about the design and development cycle. And if you see in the in the olden days, in the late 2000s, it used to take 6 years, 6.5 years for a product to get launched in the market. Now the strategy, everything is getting changed. It is taking only 2.5 to 3.5 years to launch one product. The main reason behind is like in the earlier days we used to do everything in the hand, and we used to do it by the calculation. Whatever the design we used to do, it is by the hand calculations. But now what is happening is because of the design tools at the various stages of the design cycle, they are able to compromise. I mean, they are able to shut down the time that is required for the development. And the same is like we will be able to do it with the other products also. And introducing these tools various over the various cycles also fasten up this activity also. And so it gives us a error free output delivery. So we will be seeing about like what are all the tools that are going to be used in these phases in the upcoming slides. So you can see like as a basics, like these are the five major tools that we use as a design and in a powertrain based industries. So start from the Romax, Nastron, Kisoft, Kissis, and the NX-CAD. And more or less, along with this, there are other two tools called as for the hydraulic simulations, CFD and AMISIMS. So which we have not mentioned here, but those tools are also be the part of this design activities. I will hand over this session to Deepak Kumar to explain on these tools and give a brief introduction on these things. Over to you, Deepak.
Thank you, Gautam. As all of you would have seen, Gautam gave us a brief insight on the design and development process and the product development process. So we will start with the first tool, which is Kisses. So Kisses is, in layman terms, a system level analysis and design validation software. So how you start with is you can model a kinematic system to simulate power flow and its behavior as a result of your boundary conditions. So you can see the images on the bottom of the slide. So there are three images. The first two, they depict a few uh, blocks and connections in terms of lines. So when you start with Kisses, you are presented with a blank canvas. So you can add your machine elements there. So maybe in the first example, a first image in the bottom, you can see there are there are two blue blocks and two yellow blocks. And the same is repeated in each block within. So these are connected by lines which are otherwise called as connections. So what it typically means is, say you want to model a gearbox in kisses. So if you can see the first image on the top, there's an animation. So you take this example of two parallel shafts with a set of gears and their mating gears on both shafts. So you just pull the component called bearing or a component called gear and place it on the canvas in the straight line, and you define a single shaft and you also define the other shaft. Then you connect each other. So for example, you connect gear number 2 to the mating gear down there and gear number 4 to the mating gear and vice versa. So once you do this, you then gear boundary conditions. In a gearbox, boundary conditions might be the gear ranges. So maybe you would have seen in your two-wheelers or four-wheelers, it starts from neutral to forward ranges. In cars, of course, there is reverse, but in bikes you don't have reverse. So all these conditions. So for example, in forward range 1, you would want more torque but less speed because you have to move your vehicle from rest. So in that case, maybe your input will have a higher torque and lower RPM. This repeats for the next ranges. However, as you go up, you want more speed but less torque. So each range you can give your boundary conditions and then determine what will be the output from the output shaft. So this you can model as a system in kisses. So one good advantage with kisses is it can interface with something called Kisoft. So which you'll see in the next slide. So Kisoft is generally used for designing machine elements. So if you want to design the gear in your kisses simulation, you put a block called gear and seamlessly go to Kisoft, find design the gear there, then get back to kisses and continue with your simulation. So if you otherwise have a hand calculation, you would probably have to input everything manually into kisses and then verify. But since both are interfaced, it is very seamless and the time overall is reduced. And this software is typically used in industries such as automotive, aerospace, watch industries, energy sectors, and agricultural machines. So basically, wherever machine elements are required, there you use cases. Gautam, next slide, please. Yeah. So this is Kisoft. So I was just saying in the Kisses part. So Kisoft is used to design machine elements. Machine elements can be gears, shafts, bearings, splines, joints, and the other things which you see on the screen. So it is like a formula filled Excel sheet, but it has a graphical interface in the front. So in the background, formulae and uh, design factors considered in international standards such as ISO, DIN, and AGMA are incorporated. So whenever you run your calculations, rest assured that it is running on international standards from uh, all over the world. So this Kisoft is owned by a company called Gleason Corporation. So those of you familiar with gears might know that Gleason is the market leader in gear manufacturing. So in Kisoft, to give you a better example, I would take a gear pair. So you start off with something called rough sizing. The rough sizing is where you give the general sizes of the gear, say its outer diameter and inner diameter, the face width, the width of the gear, and then you go to fine sizing. So fine sizing is where you have probably verified the rough sized gear in kisses. So your design requirements are being met. So then you come to fine sizing, where you finalize your design, you refine it. So you give values such as the tolerances for the gears, the surface finishes, and the corrections for lead or geometry. So output is in the form of reports or 3D files. So report will have all the values you need to fill to provide to the manufacturing team in the form of drawings. And 3D will be digital files which you can directly use to update your component in the 3D assembly. So usage of this software is again in the same sectors as cases, because both are usually used in tandem. Because you validate your system in one and you refine the components in Kisoft. So, uh, Gautam, next slide, please. Yeah.
Yeah, before we move to the next slide, so I would like to add few other things like based on my own experience. So what is this advantage of kisses and kissoft over the and calculations that we do in the natural way? So when I did my I filed my first patent on the gate train architecture, it took around 3 months for me to evaluate a perfect power flow. The first thing like I did was everything was on the based on the and calculations. I can still see my like bundles of papers are stacked over here in 2015. So it took around 3 months to develop around 15 concepts of the gear train architecture. But when I got introduced to these tools in 2016, 16 at Avtech, so it around 2016, 2017, I filed my second patent, and where it took around 1 month. Within 1 month I was able to generate more and more concepts with the help of this kisses. So the advantage is like whatever we do in the Excel, it is more on the iterative, like keep on, it will be changing only, and like we need to change the parameters. But in the kisses, the beauty is, as Deepak explained, there will be something called as ray diagram where you can interchange the members, and these things can be easily visualized as a graphical outputs, as well as you can have the exact values also in the kisses. That is the advantage of being using this kisses. And the Kissoft is like you will also able to detail these parameters in the Kissoft. You take out to the Kissoft and detail the gears, and whatever you do in the and calculations, those cannot be the realistic one, because the many of the factors we won't be adding in the Kissoft in the and calculations. That will be an pretty good in the Kissoft environment. Yeah, Deepak, over to you.
Yep, as Gautam rightly said, so we could have had a good idea as to how Kissoft and Kisses aid in the design process. The main intention is to reduce time and to reduce errors, because as a human being, you're always prone to errors, but softwares will typically run, will not have any errors. So that's what the advantages are. So next will be NX CAD. So as a name suggests, NX is a CAD tool. It is used to visualize your designs, refine and convert them to a manufactured product. So I would not go into detail as to what a CAD tool is, but I would want to say how NX is differentiated from the other players in the industry. So one first reason is it has a model based approach. So in other tools, you would probably start with a sketch. You would directly go into drafting, and you would give the front view, left side view, right side view, and you will end with the manufacturer drawing. So there, you would not, a layman would not be able to visualize the product, so that you have a better idea as to how it fits your design requirement. But with NX, you start with a model. You make a 3D model, then based on the 3D model, you draft. So your model and drawing are always connected. So even if you want to change your part, you first do it in the model. You can't directly change in the drawing. You change it in the part, you modify your 3D model, and then you, since both are connected, you can, it automatically updates in the drawing. So you just have to rearrange the views or just do minor corrections, and you're good to go. So this heavily reduces errors in the parts, because once you have a good visualization, you know where you're wrong or where you're right. And the other advantage is it is integrated with the PLM suite of Siemens. So PLM stands for Product Lifecycle Management. So big OEMs usually have PLM solutions, because one platform which integrates everything from concept design, business case to manufacturing and series production. That becomes one single integrator, and you have peace of mind in knowing that one platform controls every aspect of your manufacturing process, your design process as well. So these are two major reasons why NXCAD is differentiated itself from other players, and it has also resulted in more people utilizing NXCAD over other, because at the end you want a simple and error-free product, and NXCAD comes into that picture. So typical usage will be in any industry where you need 3D model. So it starts from automotive, aerospace, biomedical design, energy sector, and even home appliances. And one good feature of NXCAD is it can be combined with the CAD module. So in other softwares, you would probably want to take your drawing to the process engineering team. They will again study the part and decide what G and M codes they will have to input into the machine. But here, you can directly, with the addition of a module from Siemens, you can directly generate the G codes and M codes without the need to separately take it outside the software. So here again, it makes your process simpler. So you can design, you can draft, and also give instructions to the machine with the help of CAD module. So and the next probably would be NX Nastran. See about yeah. So NX Nastran is another one of those FEA tools available in the market. Again, I would not go into detail about what an FEA tool is. I would just want to say how it is different from the others in the field. So, I would like to show the advantage of using Nastran or others in the form of a real life scenario which happened in Avtech. So we had to make design a gearbox for yawing of a wind turbine. So many people would have seen a wind turbine, very famous in southern part of Tamil Nadu, particularly in Nagarkoil and districts surrounding it. So if you have seen, there will be a long stem on which there will be on which the turbine will be mounted. So the blades they rotate when the wind is hitting them at a specific angle. Letting apart the aerodynamic aspect of it, the wind direction changes. So it's not constant; it changes as the weather changes. So you would want the turbine to automatically rotate to match the wind direction, so that you get maximum output out of it. So you need a yawing gearbox, which is controlled by electric motors to uh, make sure you get maximum efficiency from the wind turbine. So this gearbox was given to us by an international MNC. So we started with the concept in NXCAD, and when we wanted to validate in NX Nastran, there is a defining feature of Nastran and NX in terms of FEA. So when you bring the model into NX Nastran, you would want to mesh the components first. So once you mesh it, you will probably face some difficulties as to where the mesh is not correctly connected. So you would want to, modify the part so that meshing is can be accommodated. So here, Nastran, since it's part of an NX, you can, without switching back to another software, within Nastran, you can get back to NXCAD, make the changes, and come back to Nastran. So once you do the change, in Nastran, it's just a click of the mouse to update the part. In probably, I'll give another example where if you use ANSYS and SolidWorks, you would want to take out find the corrections in ANSYS, do it in SolidWorks, get it back to ANSYS, mesh it again, and then validate. But if you see in Nastran, steps 2, 3, and 4 are avoided. You just go to next within Nastran, change the parameters, get back to Nastran, click, and your model gets updated, and the mesh also gets accommodated. So this, if you see, saves a lot of time, and we saved almost 4 to 5 months by using this, because we had a lot of iterations. It took us about 2 to 3 months just to arrive at the manufacturable design. So you can see how time-saving Nastran and NX were in this regard. So that is the best explanation I can give for Nastran. So usage will be in applications where NX is used, such as automotive, aerospace, biomedical design, energy sector, and home appliances. So over to the next software, Romax. Uh, so Romax is again an umbrella of software of capabilities which comes under Hexagon's Manufacturing Intelligence Division. So Romax is based out of United Kingdom, specifically London. So in Romax, the capabilities are similar to Keysoft and Thesis. You can make a concept layout of your uh, design in Romax concept. It is one of modules. So how Romax works is it has an umbrella. So under the umbrella, you'll have different modules. So there'll be a module for concept generation. There'll be a module for designing your component. There'll be a module to validate your component, and there's a module to do NVH and even uh, flow analysis. So uh, in concept, you model your components, and once you have a set of boundary conditions, you take it to Romax Designer. In Romax Designer, you work with the detailing of the part. So once that is done, you can validate the part within Designer, and once you are satisfied with the design constraints, you can also do NVH validation. So I'll just give a brief example, I mean brief overview of NVH, because we personally haven't worked with NVH because in Aptech we didn't have a requirement till now. Maybe going ahead, we can see how NVH can be accommodated also. So the capability of Romax, I would again take the example of the yawing gearbox for NX National NX. So once we validated the design in NX, we had to validate it in a module called Romax Build. So this was a requirement from our end customer. So Romax Wind was new to us because it is the first time we stepped in wind industry. So we went to Romax for our solution. So Romax is giving also a design consultancy service. So as you can see in the slide now, which Gautam has put, so they give design, they do design reviews. So they won't actually help you with the design, but they will tell you how it is not meeting your requirement. So once we took it to Romax Sprint, we were relieved to see our design was validated in the first try. So NX CAD and NX Nastran helped us in validating the components, whereas Romax Wind helped us in validating the complete system with respect to wind perspective. So apart from design verification, they also provide services such as manufacturing support, testing support, and after your product is out in the market, probably give you problem investigations for special cases. And they also do strategic consulting. So Romax is, as you can see, it has a big umbrella of modules. So it is a relatively new member to the industry, but